Okay, so guys, please do problem one that is on the worksheet in front of you. So how do we do that? Well, we are spinning stuff. When you spin a thing around an axis, you're gonna end up with circles.
Isn't this what we were doing before?
Yeah, this is what. Can you guys remember things from Friday to Monday? Like, come on.
I don't remember anything. I mean, highly doubtful, but maybe on a good day.
Okay, so one, like we gave you the graph, that was nice of us. Y equals negative x squared plus 1, so that's the blue curve. And y equals 0.
How do you know when it's dy?
How do you know if it's dy or it's dx? Well, you got to look at it. But first of all, the curve and the line, like what bit of the curve is pinched off, just this bit that's shaded, right?
Yeah.
So, and it says, where is it spinning around? Asher, what does the problem say in the words up top here?
XX.
Around the x-axis. So we are spinning around this line. Shoot. So we're going to get something that looks like an egg or whatever. Are the thicknesses of these little slices?
Oh, those are dx.
Those are dx.
Okay.
And my hint to you in how to set up the whole equation, once you see that, you want all of these functions as y equals stuff in terms of x, which I already have. Logan, I need to find the radius, and the radius changes, like it's skinny and little here, and then it gets bigger, and then it gets bigger, and then it gets smaller again. What is the equation that I'm going to use for that radius?
Is it upper minus
Upper minus lower. Okay, so the top curve minus 0. So the radius for that circle is just the top curve. So Carson, what's the area of my circle, the equation for my circle, if that's my radius?
Pi integral from -1 to 1 of the radius squared dx.
Okay, so you're ahead of me. The area formula, pi r squared. That was the radius. Okay. Pi r squared. And he says from -1 to 1, how does he know those numbers?
Because the intercepts.
Okay, so if I tell you, which I will tell you this on the test on Wednesday, find the intercepts analytically, not just go, well, shoot, looks like it on the graph right there. Here
No, the graph.
set them equal?
You set them to equations equal.
So, okay, so set the two equations equal to each other, which is where does this thing have intercepts? X equals plus or minus 1. So we get the answer that we said. But this is the work that I need to show that here it looks like this. That's not okay. You need to show me analytical work. -1 to 1. Keith, how would I integrate this by hand?
Ooh.
The thing that Carson set up for us. Can I just raise the power divided by the new power right now? No, because I got a thing inside too. So there's a
U substitution.
U substitution's not going to help me either.
Never mind.
Maya, what were you going to say?
Oh, I was gonna say you can't really change the whole thing, so it's doesn't have that negative part.
Well, I'm going to do what Natalie said, and
Okay.
I'm going to just multiply this stuff out. Negative x squared times negative x squared is positive x to the 4th minus x squared plus 1. So that stuff becomes. And now can I just undo power rule on each one of them? Like now it's easy? All right, so keep integrating now. What is x to the 5 raised to the power divided by the power?
2 over 3x to the third plus 9. Can I give it?
One of those worksheets. So it's not in front of you. Did anyone else not get a worksheet?
Oh, yeah.
Okay. So guys, plug in. Tell me what you get. What do you mean, wait, what?
Oh shit.
Stinky poo. You are being recorded.
I should just pay attention when you're going over it instead of trying to do it myself.
Too high.
Why are fractions so stupid? That's kind of telling people. It means it's not the fractions that are stupid.
I got the same answer.
And
No, I just. Yeah, it's 8.
Oh, never mind.
Yeah.
reduced by 3 is 2/5.
Hold up. Wait.
Did I mess up?
18 minus 10 is usually 8.
Yeah.
Yeah, it's usually 8.
Yeah.
So,
Should be 8.
stupid fractions.
Yeah, who made that?
Yep, it's not usually the fractions that are stupid. We can hate them anyway.
Yeah, that's what I got now, so.
Okay, and I cheated in here. Right here. Okay. So Carson, you said from -1 to 1, which is accurate. I see that there's a symmetry. There's the same amount of stuff on the right as the left. So I could have done this problem 0 to 1 and double it, which then I don't have to plug in all this negative crap. I can just do 2 times out here. So much easier because
It's like -2 to 2.
no. You gotta look at it and have an understanding of the graph. Like here, this one not symmetric because but from 1 symmetric, I can do that. Like you gotta look at it and understand it's an even function. The left and the right are the same amount of stuff.
Okay.
Asher?
So it's being revolved around the x-axis, it's always the x. And the opposite would be y.
Okay.
I'm like very confused on that part.
Okay, when something's being revolved around some horizontal line, and you guys ever worked on a lathe?
A what?
What?
LATHE, lathe. It's a machine that spins real fast, and you put a
No.
sharp edge on it, and you move it, and
yeah.
it's the thing that makes like curvy edged legs on a table or whatever.
Oh, I've seen that on
You see that? Okay, well,
So
so it's spinning this way, and your shape is being made by moving the little the slicey thing along that way. That's a dx thing. If the spins go this way, if the spins are going vertically, the little slicey thing goes this way. Dy difference. So, are your spins this way or that way? Like, Sydney?
That's like a real thing. It's like
Really?
always.
Yeah.
No, that rule.
Yes.
So what for like, if that one sits spin around?
Okay, we'll just one thing at a time. Sydney, did you have a question on this as it is unchanged at the moment?
Can you ever revolve something around, like something that's not horizontal or vertical?
Yes, and we don't. Okay. But, okay, so the question was, do we revolve around slanty things? We can and we don't.
Right.
However, I can still ruin your day and revolve this around something that it's not touching.
What?
Yeah, dude.
So,
But I feel like it's a little bit easier because
okay,
you can
all
just
right,
imagine
but
it.
are we okay with,
Yeah.
this is what was last week.
Yes.
Problem 2 is today, and your test is Wednesday.
Are we done?
So this, what?
We just need to learn one more thing.
This, the one more thing is right here.
Oh, yeah.
Under. Okay, so this guy, giving you the graph, y equals 2x plus 2, and you do need to be able to graph these on your own, and y equals x squared. Whoops. First thing, Jacob, how would I find the points of intersection analytically? Meaning, don't just point to the graph and go, well, it looked like they right there.
Set them equal to each other.
Set them equal to each other. So 2x plus 2 equals x squared plus 2. What now?
Solve for x.
Go for
By,
it.
subtracting 2.
You guys are so slick, like, and then you just solved the problem. Yes, which would be doing what? Subtract 2. Now what do I have?
Add 2x to the right side.
What?
When I add 2x to both sides, what do I get?
X squared plus 2x. Yes.
So what do I do?
Subtract 2x.
So see, I used to do computer science and I would get so aggravated because it would do what I said, not what I meant. I did AI in particular. If you ask the computer, do you know the time? It goes, yes. Sassy little.
What's that?
So you had to teach it manners. They were being polite. It means give them the time, not do you know the time? Yes, I do. I know it all. I know everything. Yeah. Oh, no.
We're allowed to do that.
Because if you divide by x, you're throwing away one of the answers. So I get x equals 0 and x equals 2. I wanted coordinates. Liv, how do I get coordinates?
You plug those x's back into the original equation.
Wait, why do you?
I want a coordinate because I do. So she said plug the coordinate back in. So when x is 0, y is 2. When x is 2, y is 6. It's nice that it does match up with the graph we're given. Okay, so that's finding the coordinates analytically. Cool. At least part is done. All right. Asher Wilkes, how are we spinning this thing?
Around the x-axis.
Around the x-axis? So around this guy, way down here?
Yeah.
That's a problem.
Do we just like shift it or something?
No. We can't do that this time. So first of all, what's that shape gonna look like? A donut-ish. Why is it a problem? Because it's a donut.
One of
It's
those.
like a
It's
spacer.
one of those like soccer cones you had.
Oh,
yeah.
Yeah, soccer cones.
Okay, well,
So-
Ooh, it's like a toe tap toy. This thing in the middle. So
Or like a
Do we need to
dog,
solve
like-
the area under
Okay.
one and
Okay.
subtract it from the area
So-
under the other?
So related to this, hang on. So geometry back in the day, here's my circle. Let's say that radius is, I don't know, 8. And this radius, the little one, is 6. How do I find the area of the donut ring? Sam?
Subtract the,
So
you subtract what we know from,
so is that it? No.
no.
Noah?
Isn't it that you would do define the area of the big circle and subtract the area of the small circle from it?
Yes. You've got to do the area of the whole big circle and drill out the area of the small circle. So this is, the big one is pi r squared, so 64 pi minus the inside, 36 pi, which is not just subtracting the radiuses. Noah?
So is there always gonna be like a hole in the middle that's not touching the x-axis?
If it's not touching the thing it's spinning around, yeah. Not necessarily the x-axis, but the thing it's spinning around, yeah.
You say that we don't do slanty things, but like just BC Calc or.
No, BC Calc doesn't do sucky things. Actually, in honors pre-cal, we used to do elliptical conics rotated at random like 23 degrees. It was interesting. We used to do math induction, we like all that baby math that is now an IB higher level, we did in pre-cal. We don't do that anymore. Okay, so anyway, so this, I asked this because the shape we're getting, as Mael said, is kind of a donut-y thing.
Oh.
And it's rotating around this x-axis. So visually, I have that guy that's gonna get mimicked down here. So it's kind of a trumpet bell, sort of.
Yeah.
So does the hole get bigger as it goes farther down the x-axis?
Yeah, so the whole changes and the outside radius changes as we move. All right, so first issue, Asher, first issue is you need to get an image of what is going on. And
If it was touching the x-axis, there'd be no hole already.
no, if I shifted this, like if I spun this around y = 2, there'd still be a hole. It'd just be more of a tulip than a trumpet.
What? No, but there's no hole. Yeah, that we don't.
Hold up, I'll show you in a second. But what I want to do now is find the volume of this thing. All right, to find the volume, I need to do the area.
It's like a hole.
Francis, what is the radius to the very outside line? The furthest away thing is it the straight line or is it the parabola?
I'm not sure what you're asking, but I think it's 2x plus 2 minus.
The distance from this straight line, which is this equation, to the y-axis is 2x plus 2. That is the radius to the outside shape. The hole that we're drilling out. Jackson, what is the distance from this curvy bit to the x-axis?
X squared plus 2.
So as, I don't even remember who told me, but the area of this like disk that we're finding, capital R, lowercase r, it's pi times big radius squared minus little radius squared. And that we're finding the volume of it, we need to make things move along. Dx, for what x values did we find? 0 to 2. Okay, so with the radiuses that you guys got, pi 0 to 2, big radius squared minus little radius squared. Okay, things with the test on Wednesday. It requires reading, like careful reading. Like, did I say with respect to X or did I say with respect to Y? Did I say spin it around the Y-axis or the X-axis? Did I say set up but do not evaluate? And those of you that are going to evaluate, you're going to waste a lot of time.
This is setting up, right?
This is setting up.
Here.
So, try it on your calculator, type this in and see if you can get a right answer.
But you had to pick the square of the whole thing again.
You will get a calculator on Wednesday, not used for everything though.
Will you tell us what we can and cannot use it on?
No,
Don't
it's
use
not-
it on stupid things.
It's not gonna be useful on certain things.
So did you multiply by 5?
What did you get?
30.1.
You didn't get DTC.
No, I did not get it.
What's wrong with the calculator?
We got it.
Operator error.
Yeah.
Wow.
I spread them.
Oh, because my X value is bounded to something.
I got 9.65.
Yeah, I
No, I did it.
guess.
I got like 30. Yeah. I wrote it.
Anybody get a decimal?
Yeah.
What'd you get?
I got 30.159.
Oh, I didn't.
Yes, no? Do you guys agree? Josh, you do good? Josh?
Yes,
What?
it's the same as
Why's the radius the whole thing squared minus the whole thing squared and not just like 2x plus 2 minus x squared minus 2 and then that squared?
Okay. Again, area of the outside circle. Is the area of the outside circle 10 minus 8 and then take that squared times pi? Is it 4 pi? It is not. Okay, so if this was actually drawn to scale, a radius of 2 is right in there. That area of that little tiny circle is not going to make up all of that outside, like, if you think of it as lanes on the track outside, do you have more stuff to paint in on that outside ring of the track than the inside ring of the track? If not, I'm going to challenge you to a race. I'm going to take the inside lane and I'm going to beat your ass. Ha! I am faster than you. And if I get to choose the radius, I will always win. I don't care how fast you are.
What's the washer method?
That's this.
Oh.
Does any of you know what a washer is? It's a hole in it. Right there.
Yeah,
Right.
you're right. There's a difference.
The washer or not?
We could call it the donut method or the bagel method or whatever food of choice, but it's a washer. Okay, but Josh, do you understand? It's the area of this outside track, pi r squared minus pi r squared. It's 36 pi, not 10 minus 8, which is 2 squared times pi. Okay? Good times. Can you guys set up on number 3? Try. Like, find, is it a solid thing? Or is it a thing that has a hole drilled in it? If it's a thing that has a hole drilled in it, find the big radius, find the small radius.
That one day.
Yeah. Does anyone know if the recordings for Thursday and Friday are up?
They're not.
They're not?
Thursday, I watched Thursday.
You watch Thursdays, so Thursday's up. Okay. Eric, you're done. So are you volunteering to do the problem on the board for us?
The one on the left or the one on the right?
The one on the left.
I can do the one on the left if you like.
That'd be swell.
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 How exciting.
So here, let me give you space. Since all of you have this on your paper, I'm going to cover up the one on the right.
Am I using a calculator?
Well, I'd like to just see the setup of everything.
Just the setup. Okay. I can try and do that. We'll see how it goes. So.
Can you find the points of intersection for us?
Points of intersection.
Analytically, not the point to it on the graph. Oh no, x squared equals root x. When is that?
0 and 1.
0 and 1. Show it.
Okay, let's try. It's a pretty good question.
How do we get around this? I mean, this is subtracting. No. That's not going to be helpful. Will, help him out. What does she do? What should he do?
I squared it. So
Square it.
Both sides?
yeah,
Well, if you square just one side, then you're not making it equal anymore.
and then subtract the x.
Got it from there, Eric? Yes. X cubed does not come out of both.
X does that.
X does.
Okay,
On the left one, no, I did,
then we
yeah. Yep. Could you subtract it and then just take it out x to the 1/2? Or like.
That's gross. I don't know how to solve that from there. I mean,
I don't know, that's what I did and I got the same answers.
it's a little gross. Okay, do you guys agree? So first of all,
No, we don't agree? What did I do
do you
wrong?
agree with his coordinates, 0 and 1?
Yes.
Ken,
What's
what
wrong
were
with
you-
that?
Oh, I was gonna ask, could you just add 1 to both of them if it's revolving around
-1.
yeah, -1. Or
No, because it's the difference in the air distance traveled, right?
So the distance from here to there matters. And it's not around the x-axis, it's around the -1.
Oh, we're revolving around -1?
So,
You didn't tell me that.
well, we got Sweetie, it's written.
good luck to you, Jackson.
Ah, see, that
Oh,
changes
going to the
things.
castle. Yes, okay.
That does
So-
change things a lot. Okay,
All
I
right.
can fix that.
Not- sit. So, like, read the question and be careful. Like, the picture here is, like, here's the x-axis. The ... is y minus 1. So the distance from that outside furthest away curve is, the big radius is that curve minus -1, minus the thing we're revolving around. The distance, so Carson, from the curve to the x-axis is square root of x plus 1. And then I need to take one more step down, which is another step, one more unit to get to what I'm spinning around. So the distance is square root of x plus 2. Yes?
The bounds stay the same.
The bounds that
Yes.
we're integrating over 0 and 1 stay the same. Okay, the smaller radius, the distance from the bottom curve, smaller radius was x squared plus 1 minus that -1. Logan, did you have a question? No. So these guys are 2's. So when I ask you, show your setup, this is what I want to see. Maya?
We got to write the R and all the stuff for and then just write the equation down. And then
Okay,
then-
guys, do you need to label your work? Or can I just leave floating math like this and make you guess what my radius is?
Yes.
This is showing, what Eric showed here, this is fine for finding the x values of the coordinates. Tell me that this is the large radius or the small radius. Label your work. Hang on, Morgan?
What if, like, in the problem, you do that minus 1?
Minus, like if you leave it like this.
Like, if you had that, yeah, what you just.
That's a little
underlined it in
gross.
the thing.
Okay. If I say set up and then evaluate, and you have to type it in on a calculator, you will most likely type it wrong if you have this. So it's in your best interest to do a little bit of cleanup. Maya, do you have a question? Yeah, so guys, see if you can figure out how to type it in. It's a lot of parentheses. Easy to make mistakes. Francesca, did you get an answer? 5.13, 3 decimals.
5.131.
1.
5.131.
Oh, I should check all my delta maths.
So you never want it in terms of pi?
I would prefer them in terms of pi, but I don't want 8.67 pi. I would like it as 4/3 pi or something. So if you're not integrating this by hand to get a fraction, just give me the whole decimal. But I agree with the 5.131.
Oh.
Yep.
On a test, you're at the volume equals 5.2 or the area?
Well, what is it? Is area the same thing as volume? No. So they're not the same thing. So it matters. Which one is it? When it got rotated, so we are finding the area of a cross section. The area was just that pi r squared, and then we multiplied it by a dx or a dy. It kind of plumped out. It got another dimension. Then it became volume. Okay. Here's the really hard one. You guys ready for? Woo! Undo. Here. Okay, guys, here's the really hard one.
I'm like 3/4 of the way down with the
Hey.
really hard one, and I no longer.
Do we just
feel
have to,
comfortable
like-
here.
And how do you?
I did it.
So when it rotates, does that become like a negative area?
You do not get negative area.
Oh, it's only.
So you only do the
I
big
got
R
67.8.
small R squared when it's not Did you square them?
Did you get 67?
Okay, when it makes a hole, okay. Guys, look at problem 4.
Well, that one doesn't.
Oh,
Here's-
we're rotating.
here's
around the
my
y-axis.
graph.
Or underscore.
And it's rotating around x equals -2. So
That one doesn't make
Oh,
sense.
like this.
Did you get this? So that one you do the big.
Okay. First question is, are the little slices dx or are they dy? dy. So that is a hint that everything, lower y value, upper y value, I need a pi.
So it's just right, big right, like regardless to right,
Right
minus the left.
minus the thing I'm spinning around. So here, pick a different color. The thing I'm spinning around, x -2, to the curve, the large radius, the curve, I need it as x equals y. Crap. Do I have it like that already? I do. So the large radius, -y² + 2, minus, what am I rotating around? -2.
But
So the large radius, yes?
it's already on. Like
It's-
touching.
Careful. The y-axis is right here. I'm spinning around this guy.
So if you just did it spinning around like the y-axis, that would like
Not the same thing.
how would you do it then? And it's like in the way.
Around the y-axis, I can't do that. The
Or
solid,
you have to cut it off.
okay, I can't do it around that. They won't ask you about a solid that rotates on top of itself. So big radius squared. What is the small radius? Will, what do I get for the small radius?
Y plus 2.
So y minus that, which is y plus 2.
Minus 1 and 2.
How do I get where they intersect?
Set the values to each other. Then
Factor that.
negative y plus 1 and y negative y plus 1 and y plus 2. Oh yeah, because
Is it a -2 and a +1 or a?
it's a positive 2 and yeah, and a negative 1.
Have we gotten y?
Have we gotten what?
No, I'm actually doing that.
We're doing that, yep.
As we speak.
So setting them equal to each other. And then integrate over the lower y value to the upper y value. Sam, what'd you get as an answer?
I don't have a calculator, but I have that integral down.
Well then, sweetie, you're gonna be like pushing the pencil and figuring out what this is by hand. Cause you can integrate it, expand and integrate. Anybody get a number?
0.858.
67.858.
That is correct. Thanks.
I would agree. And those of you who did it the long way, 108 over 5 pi. Okay, so these are tricky. Please do the delta math, which isn't copied yet, but it's coming right now. Will, do you have a question?
Oh, I was just wondering, like, if you put it in terms of pi, if you have to put it as a fraction or the decimal.
Okay.
Because, like, if it's not like a continuous decimal, like it's not.
I prefer exact answers, like 108 over 5 times pi. But we are letting you use a calculator. But again, my concern is you guys are gonna try and do too much on the calculator, like 2 + 2, and spend your time typing things that you actually know the arithmetic and it's faster in your head, and that you're not gonna read the directions. If I say in terms of X, I want it in terms of X. If I say in terms of Y, like, follow the directions. If I say do this one only or set up only, you'll be wasting time solving for the whole thing. So please be careful, people. So